This is where the U.S. military is testing its future, a place better known for pig races and pie contests. It's the Fairplex in Pomona, California, home to the Los Angeles County Fair. Here in the shadow of Hollywood, science fiction meets science fact, as the U.S. government's Defense Research Agency, or DARPA, hopes to uncover the next generation of robots.
What we have here is a demonstration. It's showing how far we've gotten in terms of human beings and robots working together as partners. How can the technology help those two, humans and robots, work together in disaster response, even if the communication between them is really degraded?
After 3 years, the DARPA Robotics Challenge is now in its final round. Teams of the world's most advanced engineers have built robots meant to navigate an obstacle course designed to replicate a real-world hazardous environment. And they're competing for a total of $3.5 million in prizes.
There are 8 different tasks that the teams have to do, and they have to do them all within 1 hour. And so first we're going to rank the teams based on how many tasks they completed, and then within teams that have tied with the same number of tasks, we look at when did they finish their last task. So it's task first and time second, and we don't expect any ties.
The robots are semi-autonomous, meaning they can look, think, and act for themselves to a point. Most look humanoid, like Leo.
Behind me is our Atlas robot for our use in the DARPA Robotics Challenge. Leo is a homage to Leonardo da Vinci, who had some of the first conceptual ideas of humanoid robots.
Created by a team including defense contractor Lockheed Martin. The robot itself came from Boston Dynamics, now owned by Google, but Lockheed's team provides the so-called secret sauce, the software running Leo. So, Todd, give me sort of the quick show and tell. What of this.
Leo is a...
Can I touch him?
You can touch him. He's a little bit oily. Wash your hands afterwards. All
right.
Feel free.
I don't want to break him.
So what you're seeing here, up here is his sensor head. And this is a stereo imager, so he has stereoscopic vision just like we do. And that makes basically a hemisphere of information around him. So back here, there is a perception computer.
Is that the brain?
That is the brain, essentially, of the local robot.
Weighing in at 330 pounds with a supercomputer inside, you'd be forgiven for finding Leo a little intimidating. But the team said he was still finding his feet, literally and figuratively. Right now, Leo's legs are straight, but usually they'll be like this.
That's right.
And why is that?
If his legs are straight, then he doesn't have the ability to move his hips side to side. If his legs are bent, then there's more range of motion available at his hips that he can move.
Got it. What's your favorite part?
I like the sensor head and the sensor processing most myself, though.
Really? I like the claw. Why are the red lights flashing?
So the red lights are just an indicator that the robot is on.
Leo is still not quite ready for prime time. His battery won't arrive until just before the challenge, but he has practiced over an obstacle course very similar to the real one in Pomona. The robot drives this to the location.
That's correct. The first part of the competition is the robot driving this utility vehicle.
Can Leo fit in here?
Not quite. So he's going to park, and then he's going to get out of the car, and that will be right in front of a doorway. The doorway will be closed, and so he needs to, well, of course he needs to recognize the environment, make a plan, approach the door, and try to execute
Would he like
this
open
plan.
the door like
Yes.
that?
He'll open the door. Most likely he'll be pushing the door open. And once he's inside, there'll be a variety of tasks to choose from. For this task, he'll have a cordless cutting tool, kind of a rotary tool like you may use, just buy at a home improvement store. And he needs to cut a hole through a piece of drywall. The next task would be to turn a valve 360 degrees counterclockwise, so that would be like opening a valve.
So he'll use that stick thing to just do that?
We would use the stick for that.
Okay.
And that's why we decided that we would use one stick in one hand. He'll cross over this pile of cinder blocks, and they're oriented at a variety of different heights and angles. The risk of falling is great, so we want to avoid that risk at all costs, because you really don't have a lot of second chances here. There will be 2 runs, and they take the best of both runs for the final score, but a fall is a big deal. So we'll walk over this pile. Ultimately...
Boy, that'll be easier for him than me.
Yeah. Humans are very good at this stuff.
Yeah, you do these in heels.
Oh,
You put Leo in heels. We'll see how he does. I win,
Excellent.
and I have a brain.
The course finishes with the robots having to climb a set of stairs and complete a wild card mystery challenge, something the team will have to teach the robots on the fly. However, there's a point in the challenge when all communications are lost to mimic a real-world hazardous situation. Leo has to go rogue, but the Terminator, he is not.
And if you can't communicate with Leo, will Leo just stand there, or will Leo perhaps start making decisions on what's the best thing to do next?
Leo will still make decisions on what is best to do without that approval from the human operators. But in the best case, everything goes according to the plan.
And if it all goes awry, you can't run out there and restart Leo.
I mean, if safety was a concern, we could definitely stop him. But if we do stop him, then that's the end of the run. We can't continue beyond that.
But there is still a lot machines cannot do without men.
So you can think of robotic missions in terms of their complexity. If you have an environment where the only thing moving is the robot, all the way up to working in environments where there are non-cooperative entities in the environment. If we relied on a purely autonomous approach, you would be sort of out of luck at that point.
For the final, each team has 2 chances to complete the challenge in 1 hour. But reality turns out to be more comical at times than scary. The mystery challenge turns out the robots have to either pull a lever or take a plug out of one socket and insert it into another. Just 3 teams out of 23 complete all the tasks, and the $2 million first prize goes to Team Chaos from Korea, which finished the course in just under 45 minutes. Leo did not make it that far, but Lockheed still considers him a win. His technology can be integrated into other products. But bottom line, it turns out taking robots to the next level is harder than you think.
This program is creating a community of researchers that are trying to extend the state of the art of robotics. And this is great. A lot of connections are being made between members of the various teams, and we're all building a really close relationship with each other to improve the way our systems work and improve the way we can overall control humanoid robots.
That's why DARPA held the competition, even though many of the international teams would not be required to share their technology with the U.S. military. Instead, the hope here has been to move the science along, one faltering step at a time.
The holy grail in robotics right now is the ability for robots to work in ways where they don't require one human being for each robot in supervision. So can we somehow make robots help us to be more productive?